The problem is states that prove that the points A, B, C, and D, four coordinates given of each, are the vertices of a square. Okay. Let's list down the vertices first. The given points are A 2 3, B minus 2 and 2, C minus 1 minus 2, and D, the fourth coordinate is 3 minus 1. These are the 4 points given. You need to show that they form a square. Let us draw a rough quadrilateral looking like a square. But actually may not be a square because we don't know till now. We need to show that this is a square. Okay, now how to prove that this is a square? First of all, you need to calculate all the distances AB, BC, CD, and AD. Once you calculate the distances, you show them to be equal. Okay, once you show them to be equal, now this is a quadrilateral uh, where it may be a rhombus also, right? All the sides are equal. It may be a rhombus. So what distinguishes the rhombus from a square again? The length of the diagonals. You can show that the diagonals are unequal, or just as in the last class I showed you that if you can show that one of the angles is 90 degree, then you can um, say that it is a square. So let us calculate the distances. A is 2 3 and B is minus 2 2. So therefore what is AB? Root over of minus 2 square plus 2 minus 3 square. This is root over of minus 4 square plus minus 1 square. This is root 16 plus 1. Root 17 units. Okay. Prime number under radical cannot be done anything. You cannot do anything with this. Okay. And the next one is the distance BC. Let's write down the coordinates. Now we calculate BC. I'm doing this directly. See that there's a minus 1 here and there's a minus 2 here. So minus minus combined to give you this plus sign. Okay. This is root over of 2 minus 1 is 1 square plus minus 4 square. So again this comes to 1 plus 16, which is root 17 units. So BC is also root 17 units. And CD, C and D. Coordinates of D is 3 minus 1. CD is root over of 3. Again minus of minus 1 will give you a plus 1. And again here minus of minus 1 and minus of minus 2. So again this comes to root 17. 16 plus 1 is root 17 units. And finally the distance AD. So the coordinates of A here is 2, 3 and D is 3 minus 1. Root 17. So all lengths are coming to be root 17. So thus AB is equal to BC is equal to CD is equal to AD is equal to root 17 units. Hence ABCD is a square. Hence ABCD may be a square or a rhombus. That's right. Hence ABCD that is ABCD may be a square or a rhombus. Let us now calculate the distance, the diagonals in fact. This diagonal, let's calculate first AC. So here A is 2, 3. C is minus 1, minus 2. So therefore distance AC minus 1 minus 2 square plus minus 2 minus 3 square, which is root over of minus 3 square plus minus 5 square, which is square root of 9 plus 25, which is square root 34 units. Now this is a pure surd, you cannot do anything with this, keep it at square root 34. So AC, diagonal AC is root 34. We now proceed to calculate the next diagonal, PD. B is minus 2, 2 and D is 3 minus 1. Therefore, BD is root over of 3 minus of minus 2 square plus minus 1 minus 2 square, which is square root of 5 square plus minus 3 square is square root 25 plus 9 square root 34. This shows that the diagonals are equal. See, AC is also 34 and BD is also square root of 34. So thus AC is equal to BD is equal to square root 34. What can I write? Thus, that is, I can write in fact, that is ABCD is a quadrilateral, all of whose sides are equal, all of whose sides are equal, and which has equal diagonals or diagonals of equal length. Hence, ABCD is a square. You can do the other way around also, as I showed you. That is, what you can show is you can show that AC square is equal to AB square plus BC square. You can show this, conclude that this angle is 90 degree, and also you can say it is a square. Okay, that is also another way of doing. So that is this problem. Now let us move on to the next problem, 23 part 2. Look at 23 part 2. The question here is, name the type of quadrilateral formed by the following points. So the given points are, let's list down the point first. Let us say we call the point 45 as A, the point 76 as B, the point 43 as C, and 12 as D. Try to take whenever this such type of question is given, you will take the coordinates in order. Okay, the first one has first coordinate, second one has the second coordinate, that is A, B, C, and D. Okay, don't take this as C and take this as B, because this coordinate is first and then this. So therefore, whenever the question will be given, the coordinates will be given to you in a certain order. Okay, so this is something that you have to remember. So we have taken A, B, C, D as the four coordinates. Okay, let us now calculate the distances. Since we know only distance formula for the time being, we will use only distance formula. So let's calculate distance AB. Root 10. The first distance that we have got is root 10 units. So pure surd, keep it as a pure surd. You cannot as it is convert to your mixed surd. Root 10 cannot be converted to a mixed surd. So here CB 76 and C is 43. We are getting this as 9 plus 9. In fact, we are getting this as root 18. And root 18 when converted to a mixed surd, prime factorize this 2 into 3 square, which is root 2 into root 3 square, which is 3 root 2 units. Fine. This is BC. Let us now calculate CD. C is 43 and D is 12. Okay, so this is minus 3 square plus minus 1 square. This is 9 plus 1. Again, we are getting this as root 10 units. Okay, and last distance is, let us draw a quadrilateral and uh, try to have an idea of the coordinates. Any quadrilateral you draw. So you have your A 45, B 76, C43 and D12, these. Okay, and we have already calculated distances AB, BC, CD. Now it's AD's turn. So A is 45, D is 12. Therefore AD is root over 1 minus 4 square plus 2 minus 5 square. And this is square root minus 3 square plus minus 3 square, which is 9 plus 9, which again comes to root 18. So it's equal to 3 root 2 units. So what do you see? In this quadrilateral, you're getting, what are the lengths that you're getting? You're getting this as root 10 AB. You're getting this as root 10. You're getting this as 3 root 2. And you're getting this distance as 3 root 2. So what do you see? That the opposite sides of this quadrilateral are equal. So you can write that ABCD is a quadrilateral. Thus AB, since for that, since AB is equal to CD and AD is equal to BC, therefore ABCD is a quadrilateral with opposite sides equal in length. Equal in length. So what can it be? Which quadrilateral has opposite sides equal? A parallelogram has opposite sides equal. Cannot be a rhombus because rhombus has all sides equal. Cannot be a square also because square also has um, all sides equal. It can either be a
Rectangle
parallelogram. Yes.
or rectangle.
Rectangle. Yes. Can be a parallelogram. Can be a rectangle. Okay. But what is the difference between a parallelogram and a rectangle? The difference between a parallelogram
So,
and a rectangle. Yes. Tell me.
so rectangle has all the angles 90 degree and parallelogram does not have.
Yes. Rectangle has one angle 90 degree. If you can say that will be sufficient. And if you can show one angle is 90 degree, then you can say that it is a rectangle. Okay, that is something you can do. Otherwise, what else can you do? You need to show one angle to be 90 degree. Any other way out of this?
Diagonals are equal.
Diagonals are equal. So diagonals are equal, but still, yes, diagonals are equal. You can show that the diagonals are equal in length, and therefore you can say mm, it is
Rectangle.
a rectangle. Otherwise, if the diagonals are not equal in length, then you say it is a parallelogram. So therefore, you say that is ABCD is either a parallelogram or a rectangle. Or a rectangle. We now proceed to calculate the length of the diagonals. Okay, do it here. First diagonal is the diagonal AC. This diagonal. Okay, it's AC. So here A, the length of the diagonal, the coordinates A is 4, 5, C is 4, 3. So 0 square plus minus 2 square. This is root over of 0 plus 4. Square root 4, 2 units. Okay, that is the diagonal EC. Let us now proceed to calculate the diagonal BD. B here is 7, 6, and D here is 1, 2. Therefore, what is BD? It seems this is going to come unequal. Let's see. Root over of minus 6 square plus minus 4 square is root over of 36 plus 16, which comes to root 52 units. No need to convert to mixed third because we just need to check whether it is equal. AC and BD are equal. So what you see here is AC and BD are of different lengths. Therefore, AC is not equal to BD. That is, diagonals are unequal. Diagonals are unequal. Hence, that is, or let's say, let's write this first. What kind of a quadrilateral this is? That is, ABCD is a quadrilateral with opposite sides equal and diagonals of unequal length. Hence, ABCD is a parallelogram. That's it. Okay, that is the solution for this one. And any questions on this problem? If not, then I can move on to the last question of this exercise and finish distance formula. See, last question. If two opposite sides of a square, so it is given to be a square, the quadrilateral is given to be a square, and the opposite sides are given, opposite vertices are given, 3, 2, and um, 3, 2, and minus 1, minus 2. Find the coordinates of the other two vertices. Fine. Question number 25. Let us draw a square. This is your square, ABCD. And what are the vertices given? Opposite vertices are given. So 3, 2, this is one vertex, and the other opposite vertex is minus 1, minus 2. You can also take, instead of A and C, you can take B and D also, no problem. Okay. Find the coordinates of the other two vertices. That means you now have to find out the coordinates of B and D. So how will you find out the coordinates of these two vertices? Join this. Okay. And so you can calculate the length of EC. Okay. If I consider the vertex of B as x1 y1, say, Okay, then AB must be equal to BC because it is a square. All the four sides are equal. Okay, so first condition is AB is equal to BC because the all the sides are equal. So here A is 3 2 and B is x1 y1. Let's write it first. Let's say B is x1 y1 and let's say D is x2 y2. It's going to be a long problem. Let the coordinates of B and D be x1 y1 and x2 y2 respectively. Okay, so therefore what is A here? A here is 3 2 and B here is x1 y1. So calculate the distance AB. Distance AB here is root over of x1 minus 3 square plus y1 minus 2 square. This is distance AB. Now we calculate the distance BC. Write down the coordinates. B is x1 y1 and what is C here? Minus 1 minus 2. So therefore BC is root over minus 1 minus x1 square plus minus 2 minus y1 square. This is what? Okay, AB and BC. And we know that this is a square, so AB must be equal to BC. So AB is equal to BC. What does it mean? AB is equal to BC. It means root over of x1 minus 3 square plus y1 minus 2 square is equal to square root minus 1 minus x1 square plus minus 2 minus y1 square. So in order to remove the radical, you square both sides. Squaring both sides, we get you can remove the radical. Okay, so that means you can before expanding, let us do just a small step that I had shown you earlier also. Whenever you have a whole square, whenever you have a whole square here and you have both a and b negative, you can write this as minus 1 plus x1 square 1 plus x1 whole square plus minus 2 plus y1 whole square. Now you can comfortably write this as 1 plus x1 square plus plus y1 square. Now you expand by a minus b whole square formula and a plus b whole square formula. A square minus 2ab plus b square plus a square minus 2ab plus b square. A square plus 2ab plus b square. A square plus 2ab plus b square. This is how you expand. Now see, x1 square and y1 square will cancel from both sides to give you an equation in x1 and y1. So x1 square will cancel. y1 square, y1 square is going to cancel. So that's now you're getting only x1 and y1. So let us write this equation in x1 and y1. So what you take everything to one side. So you get minus 6x1 minus 2x1 minus 4y1 minus 4y1. Okay, in fact, okay, yes, they are different signs. Minus 4y1 minus 4y1. And this is 4. So writing 2 square, let us write 4. So this is plus 9 plus 4 minus 1 minus 4 equal to 0. Take everything to one side. You get minus 8x1 minus 16y1. And this is 13 minus 5. 13 minus 5 is also 8, right? Plus 8 is equal to 0. So you can take the 8 again that side. You can take 8 minus 8 common. You will get x1 minus plus twice y1 plus 1 is equal to 0. That means you get x1 plus twice y1 plus 1 is equal to 0. And x1 plus twice y1 is equal to minus 1. This is your first equation. Okay. You will get your second equation in x1 y1 also. Can anyone tell me how to get the second equation? I'll complete this in the next class. This is going to be a little long. So can anyone tell me before I stop? Can anyone tell me how to get the second equation?